Uh, Today, my topic of discussion is solution of quadratic equations, Indian methods. So I will not be focusing only on the Bharati Krishna Tirtha's method, but I will have a quick round journey, what can be said, of the solutions of quadratic equation in India from ancient times. So Shulva Sutra are the scripts on geometry. The time period not later than 800 BC, means nearly 3000 years back. These are the scripts related to geometry, no doubt. But while discussing the geometrical constructions, they discuss the topics from algebra also, because they needs, while constructing some peculiar type of Vedis and Chitis and etc., they need quadratic equation. So the equations which they tackled at that time, remember 2800 years back nearly, are of this type. 972x square equal to 972x plus m. M is arbitrary. So that m changes according to the construction. But they need to solve this, and they have solved this successfully for the construction purposes. And the problem was enlargement of isosceles trapezium. So given an isosceles trapezium, they want to enlarge it to a particular dimension. So they have the results done about this 972x square equal to 972x plus m. But because it is a book on geometry and particularly related with Yagya constructions, they are not given any method how they are solving. Similarly, they tried enlargement of falcon shape altar, and this particular enlargement demands the solution of such type of equations: 7x square plus x by 2 equal to 7 by 2 plus m. Again, m is arbitrary, which can be determined according to the situation given. Now then, Arya Bhatia has written a script, we all know, Arya Bhatia, in 499 AD. This particular script has a 33 verses on Ganita as a Ganita Pada, and in one of the verses, he has given the rule for finding the number of terms in AP when the sum is given. First term and a common difference of AP is known. So the problem is like this. I have a formula n by 2 equal to twice a plus n minus 1d for finding the sum, no doubt, where a and d are and n has usual meanings. But the problem is not to find s or the sum, but to find n when a, d and sn is given. And if this is the problem of where we need to find n and not sn, we have to solve a quadratic equation, n square plus twice a minus d into n minus twice n equal to 0. Without solving such type of quadratic equation, we cannot find the value of n. This clearly shows that even at the time of Arya Bhatia, they know how to tackle the quadratic equation. Again, Arya Bhatia has not given any method how he has got it. Possibly he has assumed that everybody knows, and his intention was not, the topic was not on the quadratic equation. That's why he has not given any particular formula to solve it. A correct formula for solving the quadratic equation is first given by Brahmagupta in his script Brahmasputa Siddhanta. There is a chapter called Kuttakadhyay. Kuttakadhyay is another name for algebra. And in that Kuttakadhyay, 44 verse, I will not go into details of the verse, I will just read the translation. What is the formula? 4 times the coefficient of the square term multiplied by the constant term is added to square of the coefficient of middle term. Square root of this minus coefficient of the middle term divided by twice the coefficient of the square term gives the roots. That is what the translation goes. Then what will be the mathematical form of that? Indians always use the form of the quadratic equation ax square plus bx equal to c. We usually use ax square plus bx plus c equal to 0. But in Indian tradition, it was equal to c on the right hand side. So if this is a given equation, then coefficient of x square will be a, coefficient of the middle term will be b, and constant term will be c. So he's saying exactly this. What will be the root? Root will be equal to plus or minus under root of 4ac plus b square minus b divided by twice a. So just you read the translation and its mathematical formulation, you will understand the correct what Brahmagupta is saying. So this is not a strange formula to us. Exactly same formula we use in our books or in our practice. But why it is plus or minus 4ac plus b square and then minus b? Only because the assumed equation is equal to c. If I assume ax square equal to bx plus c equal to 0 or minus c equal to 0, whatever the situation, then I will get the routine formula. Minus of b plus minus b square minus 4ac upon twice a. So giving a formula for solving a quadratic equation, the credit goes to Brahmagupta first. And time for Brahmagupta is 628 AD. As you can see on your screen, 628 AD. So in 628 AD, so nearly 2000 or minus some years back, Indians know the formula for solving a quadratic equation for all values of a, b, and c. Then the modified form we are using in our syllabus without naming or without giving the credit to Brahmagupta. Then comes another mathematician named as Sridhara. He has given what we used to call today as a third term method. The same, I'm quoting from Bhaskaracharya's Bijganita book. He has also quoted Sridhara as saying that Sridhara has given this rule. The third term method, which we used to apply today for solving a quadratic equation, is different than Sridhara's method. And Sridhara is saying a simpler way to solve a quadratic equation by finding the third term. By finding the third term means we complete the square and then solve it. Let us have a mathematical interpretation. Again, we start with ax square plus bx equal to c. What Sridhara says is chaturahata, means multiply both sides by 4a and add b square. First step, multiply both sides by 4a and then add b square. This will give me this equation, 4a square x square plus 4abx plus b square. I am adding b square both sides and multiplying by 4a. So right hand side will be 4ac plus b square. Now we observe that the left hand side is a perfect square, 4a square x square plus 4abx plus b square of 2ax plus b. So I write 2ax plus b whole square is equal to 4ac plus b square. Taking roots of both sides, I will get the formula which Brahmagupta was saying. X is equal to plus minus root of 4ac plus b square minus b upon twice a. So by same way, we can have a simple derivation of the known result. See, I will do that for you. Derivation of the current formula. We apply very slightly complicated method to derive it, but see by Sridhara's rule how it can be derived. Assume the equation ax square plus bx plus c equal to 0. We used to do that always. Multiply by 4a and add b square. That is what is Sridhara is concisely saying. Equation becomes 4a square x square plus 4abx plus 4ac plus b square equal to b square. Now transfer that 4ac to the right side. Then remaining three terms are the perfect squares of 2ax plus b whole square equal to b square minus 4ac. Taking square roots and finding the value of x, we will get the known form of the Brahmagupta's result, or known form which we used to apply in our syllabus. So within 3 steps, we can derive the current formula by Sridhara's technique. And now just go to home, or you might be remembering what we used to do to derive this result is we divide by a first, and then add b square minus 4a, b square plus 4a, etc. And then remaining things. But that method which used to apply in the syllabus or in the school naturally generates the fractions. Fractional term like b square minus 4a is b square minus 4a. To avoid that fractions possibly, Sridhara has suggested multiply by 4a and then add b square, so that slightly original numbers ABC increase to 4a square or 4ab and 4ac. But finally, it reduces to a very simpler form and its deduction. Let us solve some problems by applying Sridhara's method. Because we are familiar with this result, so I'm not interested in giving you some examples based on this Brahmagupta result, minus b plus minus. I will directly move to Sridhara method and compare it with current method. Let us solve this equation. Multiply both sides, 3x square minus 17x is equal to 10. Multiply by 12 and add minus 17 square. We will get 13x square minus 204x plus 289 equal to minus 120 plus 289. This much part, if you can handle easily, multiplying by 12 and add 289, then the rest of the things are easy. It is 6x minus 17 square equal to 169. 169 is a perfect square. So when we take square root, we will get 6x minus 17 equal to 13. And the roots are 5 and 2 by 3. When we solve that equation, 6x minus 17 equal to plus 13 will give me 5. Minus 13 will give me 2 by 3. Now let us have what we do in current situation. We first divide by 3 both sides. So we get x square minus 17 by 3x plus 10 by 3. Then we add both sides, 289 by 36. Now just start comparing. Similar numbers are appearing Sridhara method and current method, but in a different form. 289 is appearing again. But my addition of 289 and 336, and then I have to add that fraction to give me x minus 17 by 6x whole square equal to 169 by 36. And the answers are same. No doubt answers will be same. So just compare what Sridhara has said and what current method is applying. And in all cases where we need to solve a quadratic equation, I find that Sridhara's technique is simpler to apply and get the answers a bit quickly than the current method. Let us have one more example. Yes. Okay. Solve. This is a simple one. I agree. In the previous example, I have purposely taken some bigger numbers. X square minus 3x is equal to 88. Multiply by 4a, a is 1. So I have to multiply by 4 to get, and then add minus 3 square equal to 9 both sides. This will give me 4x square minus 12x plus 9 equal to 352 plus 9. 8 into 4 is 352. So 352 plus 9. Left hand side is a square of 2x minus 3 whole square, and right hand side is 361 or 19 square. Again perfect square. So answers are 2x minus 3 plus or minus 19, and two roots are 11 and minus 8. Of course, by observing the equation, we can write the roots straight away. I agree. But just to explain you the Sridhara method, I have selected that. Let us try one more. 15x square plus x equal to 2. Start multiplying by 4a, means here we need to multiply by 60 and add 1. 1 square is 1. So multiply both sides by 60, add 1. You will get a perfect square on the left hand side. Right hand side will be a perfect square number. Left hand side will be a perfect square expression. And you can find the roots. I hope you will be able to do within a minute. First term. Second term will be 900x square plus 60. I'm multiplying by 60. Yes. So don't worry about the numbers. Don't fear about the numbers. You are Vedic mathematics students, so no need to fear for multiplication. Then 30x plus 1 equal to 11 square. Give me 11 and 1 by 3 as the x equal to 1 by 3 one root. And x equal to minus 2 by 3 will be the second root. Minus 2 by 5, sorry. Now I am confident that you have got the control over the Sridhara method, and I'm very sure you are going to apply it in future also. Now we come to another method, which is a Vedic mathematics method given by Swamiji. Again, the same all-time great sutra, Urdhva or vertically and crosswise. Actually, in the book, Swamiji has given 2 more methods for solving quadratic equation. One is by Adyam Sutra, as it's called Adyam Adyena Antyam Antyena. And another, very interestingly, he is saying us to differentiate the given quadratic equation. I repeat, what is the suggestion of Swamiji? Those who have gone thoroughly with the book, studied that book, at one place, Swamiji is suggesting to differentiate that given quadratic equation and equate with the discriminant. Means 2ax plus b will be differential coefficient equated to under root of b square minus 4ac, and that is our standard result. So instead of even remembering the formula minus b plus minus etc., if you remember to differentiate and forget about the differential, if you don't want to use that word differentiation, just remember for ax square plus bx plus c equal to 0, roots are 2ax plus b equal to under root b square minus 4ac. You are through with the problem. But still, this Urdhva method is easy and practicable for students and teachers also. This method is, I must say, not discussed by Swamiji. But the power of the Urdhva Sutra is such that indirectly we are using this method in our classes without knowing that we are applying the sutra with Urdhva. Let us see what I am saying. Again, I consider the equation ax square plus bx plus c equal to 0. Now, what is the suggestion? Write the factors of a. Consider the factors of coefficient of x square, that is factors of a, and consider the factors of c. Just ignore b for a time. We consider 2 factors of a, 2 factors of c. Write them column wise like this. A1, A2, factors of a. Factors of a means a1 multiplied by a2 should be a, and c1 into c2 should be c. So a is to be split into 2 numbers whose product is a. Similarly, we write the factors of c, c1, c2 vertically, but not horizontally. Don't write a1, a2. You have to write a1, a2, and then c1, c2. Once we, and which factors are to be selected? When I say write the factors, natural questions is which factors are to be selected and in which order they should be written. The order and the selection depends on a condition that actually we have applied the Urdhva form. A1 into A2 equal to A, C1 into C2 equal to C. That much we have done. Now remains a crosswise form. So we will select the form A1, A2 and C1, C2 in such a way that the product of the cross A1 into C2 plus C1 into A2 will be equal to B. So factors are to be selected in a such a way that the cross product, Tiryak Gunakar, that cross product A1 into C2 plus C1 into A2 or A2 into C1 is equal to B. Once that is achieved, and this will be easy after some good practice, you can just write the factors so that the cross product is equal to B. Once that is done, everything is done. Means we can declare that A1 plus C1 is one factor. Sorry, A1x plus C1 is one factor. And second factor is A2x plus C2. And if we want to factorize the equation, but what are the roots then? Even from this table, A1, A2, C1, C2, I can directly write the roots as minus of C1 upon A1, directly roots. Once I arrange the factor this way, first root minus C1 upon A1, second root minus C2 upon A2, full stop. Job is over of solving a quadratic equation. So where is the skill? The skill part is only that we need to select proper factors of A and C, arrange them in an order such that their cross product gives the answer for coefficient of X in the given equation. Then if you want to write the factors, write the factors. If you don't want to write the factors and directly if you want to write the roots, you can directly write minus C1 upon A1, minus C2 upon A2 as the root. And our problem is solved. So this is the power of a sutra urdhva tiryabhyam. Actually, this crosswise technique is there in the syllabus, but not without any name for urdhva tiryak sutra, etc. We used to do these things everywhere. I agree that. So let us have one or two examples so that we can have a correct command over it. Again, I am taking a little bit complicated equations so that simple equations can be solved anytime. 6x square plus 19x plus 10 equal to 0. So I will select factors of 6 and 10 in such a way that their cross product is 19. So 3, 2 are the factors for 6. And then I select 2, 5. So that the product is 3 into 5 plus 2 into 2 for 19. What I am saying, selection proper, if I write 5, 2, then I will get 3 into 2, 6 and 2 into 5, something different number than 19. So that adjustment of the second factor or a proper choice for a second factor, they are writing in a proper order is important. Once this is done, 3x plus 2 is one factor, 2x plus 5 is another factor, minus 2 by 3 is the root, first root, and minus 5 by 2 will be the second root. So by just observation, I will be able to write the either factors or the roots. Now consider this example. 12x square minus 17x minus 7 equal to 0. Slightly complicated when there are minus signs, but factors of 12 and 7. Remember, 7 has only one factor, 7 and 1. 12 might have more factors than 1. So I will first write the factors of 7 and then arrange the factors of 12 so that the product is minus 17. So for minus 7 and 1, if I write the factors for minus 7, then there is no choice for me to write a factor 4, 3, so that 4 into 1 and 7 into 13 plus will give me minus 17. So observation, Vilokanam, as what Swamiji was always saying, is a very important aspect in Vedic mathematics. You need to observe the equation first before start solving. On observation, when I observe that, oh, minus 7 has only one choice. Either it is minus 1 and 7 or minus 7 and 1. I select minus 7 and 1. Then I can write 4, 3. But by practice, you may fail in first attempt. You may not get the cross product equal to minus 17. But that practice will give you some hints how to choose the factors. Naturally, the answers are 4x minus 7, one factor, 3x. Remember, factors are to be written horizontally. Don't write the factor 4x plus 3. No. Or minus 7x plus 1. No. The factors will be 4x minus 7, horizontal choice, and 3x plus 1 to give me the roots 7 upon 4 and minus 1 upon 3. Now I am very sure you start feeling more comfortable with the method. So I have one more example for you. Try this. Again, simpler. 3x square plus 7x plus 2 equal to 0. Try yourself. I will give you 15 seconds for that only. Start. Hope you are reaching the answer. Again, no choice for 3 and 2. Only 1, 3 and 2, 1 are the factors. You have to arrange so that the sum is 7. Nothing special in it. I'm very sure about it. I have no choice. 3 has factor 1, 3 and 2 has factor 2, 1. Just I need to arrange them so that the product is 7. X plus 2 is one factor, 3x plus 1 is another factor, equated to 0 or directly from minus 2 upon 1. And try this now. Slightly difficult, I agree. At x square minus 22x plus 15. You have to give the time. You may get in one stroke, but if not, try another factor or another order, both ways. Again, 15 has no choice. 3 and 5 or 15 and 1. See which factor works. 8 has only two choice, 2, 4, 8, 1. Arrangement of the factors will be, yes, 2, 4 and minus 3, minus 15. Because I want the cross product to be minus 22. I must select minus 3 and minus 5. You can have the answer now, straight away. You can write the factors and roots. I'm very sure you're getting the answers which you're observing on the screen. 3 by 2 and 5 by 4 as a root. Try this. Find the roots of the equation 24x square minus 25x plus 6. I'm sure you have selected the factors of 24 and 6 so as to get minus 25. So the factors are 8, 3 and minus 3, 2 again. There is plus 6, but I want the product minus 25. So instead of selecting 3 and 2, I will select minus 3 and 2. So I will get the product minus 25. 16 and minus 9. Minus 16, minus 9. Yes. And the answers are 8x minus 3 and 3x minus 2 factors. And the roots are 3 by 8 and 2 by 3. Straight away from the factors or by equating to 0, whatever you prefer. There are cases where we don't need factors. We need only roots. In that case, you can jump over to roots straight away after you arrange the factors. So you need not write the factors and then the roots. You can directly write the roots. By observing 8, 3 and minus 3, 2, it will be minus of minus 3 by 8, 3 by 8, first root, and minus of minus 2 by 3, 2 by 3, second root. Now, I have brought you one example from a famous book, Lilavati. which is like this. In the battlefield, Arjuna picked some arrows to kill Karna. So we know there is a war between Arjuna and Karna. That situation is brought to the mathematical quadratic equation problem. So what he did, he diverted all of the arrows from Karna by half of the picked arrows. So whichever arrows he picked, half of it he used to divert the arrows coming from the Karna. Secondly, second data given, he killed all the horses of chariot by 4 times the square root of the number of picked values. Here exactly that quadratic equation form appears. He killed the horses by 4 times the square root of the number of picked arrows. Third data given, he used 6 arrows to dethrone the Shalya. We know Shalya was his Sarthi. Shalya formed the chariot. Then he used 1 arrow each to cut the umbrella, flag, and bow of the Karna, that is Chhatra, Dhwaja, and Dhanushya, and beheaded him with 1 arrow. So he killed Karna with 1 arrow. This was the data given by Bhaskara. And then he is asking us to find if all the arrows are used, how many were picked initially. From where we get the sense that it may be a quadratic equation? By the data given, 4 times the square root of the number of picked values. So let us solve it. How? It is easy finally, though data is, word problem is slightly complicated. X square be the number of arrows picked by Arjuna. I have purposely selected X square only because what is said in the data is 4 times square root of the picked arrows. If I select X, then I have to write 4 root X. Then I have to square it. Of course, it is solvable, but better to start with X square. With the number of arrows picked by Arjuna, half of it used means X square by 2. 4 times square root means 4x. 6 for Shalya, 1 each for umbrella, flag, and bow means 9, and 1 for beheading the Karna means 10. So what Arjuna has done, if he picks X square number of arrows, he is using X square by 2 for some purpose, 4x for another purpose, and 10 for last purpose. So I will get a quadratic. X square minus x square by 2 minus 4x minus 10, because all are used, equal to 0. It is said all are used, nothing remains with him, so equal to 0. So I got a quadratic. I need to solve it. It takes its simple form, x square minus 8x minus 20. And by observation, I can see that x minus 10 into x plus 2 equal to 0. No need to go any method. Minus 20 is there and minus 8 is there. We can arrange by practice. Otherwise, you can apply any one method you like. I advise to apply Urdhva Tiryak always. Now, 2 answers, x is equal to 10 and x is equal to minus 2. Because x square is the number of arrows picked, we ignore the value x is equal to minus 2. Minus 2 cannot be number of arrows picked. So 10 is the number, but that value is x. And my initial assumption is x square is the number of arrows picked. So answer will be 100. So from the given data, we can say that initially Arjuna has 100 arrows and he used 100 arrows in the sequence described in the problem. Of course, this is a not the actual problem as we can understand. Just he has used the situation to create a problem which finally leads to solution of the quadratic equation. And Lilavati is famous for all such type of problem. There are many problems, you will not believe me. Many problems which finally turns into the quadratic equation. We need to solve a quadratic equation. Initially, when we read a problem, we don't feel like that. But once we start solving and deciphering that verse and deciphering that translation, then we will remember that. You will understand that we are getting actually a quadratic equation for us to solve. And of course, that can be done anytime. Now, let me move to one special type of quadratic equation, which is discussed by Swamiji again. And many times we need such type of quadratic equation. That special type is x plus or minus 1 upon x is equal to a upon b. Of course, b not equal to 0. Two conditions. Left hand side is sum or difference of reciprocal terms, x and 1 upon x. So sum or difference of reciprocal terms. And right hand side is a rational number. This is the situation in hand. And of course, when it is sum or difference of reciprocal numbers like x plus 1 upon x, we are going to get a quadratic when we simplify it. But what Swamiji is suggesting us, don't simplify. So don't try to get a quadratic equation out of it and then apply a method. If right hand side is a rational number, then you can solve it under some condition, equation, without simplifying the given x plus 1 upon x equal to a upon b. So what is that method? Method starts like this. We want to find the roots of the quadratic equation x plus or minus 1 upon x is equal to a upon b. First, concentrate on that denominator b. That denominator b, I will factorize. Means I will find two factors, two values, in such a way that sum of their squares or difference of their squares, c square plus d square or c square minus d square equal to a. One way I should get the answer. If not, then of course method does not work. Remember that this is not a particular case. So particular fractions will be useful. Some may work, some may not work. Always you. And the beauty is, if this particular method does not work, it will be a perfect square quadratic. You are going to get either irrational root or even the complex roots. So that if when we want to get the rational roots, I will get the value of b, factors of b in such a way that c square plus d square equal to a or c square minus d square equal to a. So what I will get after this situation? On the right side, I will write a equal to c square plus or minus d square upon c into d. When I simplify that, we get c upon d plus or minus d upon c. So I have one sum of reciprocals on the left side, another sum of reciprocals, c upon d plus d upon c on the right hand side. So from the given quadratic, I change it to two sides of equal forms, sum of reciprocals. Once I achieve this, Swamiji tells us that first root of the equation is c by d, second equation will be plus or minus d by c, simply. Though I'm explaining it in more detail, in practice, you will not require more than 15 seconds to solve such a problem. Once you achieve that, once we are able to write a equal to c square plus d square for factors of b, then you need not do any simplification, nothing. Straightway answer will be c upon d first root. Second root will be plus or minus according to expression in the numerator. If it is c square plus d square, I will get d upon c value as a root. If it is c square minus d square, I am expressing a in terms of the factors of b. Then my second root will be minus d upon c. Let us move to example so that you will get a beauty of the situation. One example only. X plus 1 upon x is equal to 29 upon 10. So factors of 10, 5 to 5 square plus 2 square is 29. So I am through with the situation. Factors 10 and 5, I select for 10. Then 5 square plus 2 square equal to 29. So for 29, I will write 5 square plus 2 square upon 5 into 10 in the denominator. And simple observation will give me 5 by 2 plus 2 by 5. So format becomes same. Sum of reciprocals x plus 1 upon x on left side. Sum of reciprocals 5 by 2 plus 2 by 5 on the other side. So straightway the roots of the quadratic equation, 5 by 2, one root, 2 by 5, another root. Many times we come across such situation where the terms given are the sum or difference of the reciprocals. That's why Swamiji has given a method for it. Of course, everything is by observation. No sutra involves in it practically. Now solve this slightly complicated situation. x upon x plus 3 minus x plus 3 upon x equal to 15 upon 56. But my observation tells me that the left-hand side is difference of reciprocals, x upon x plus 3 and minus x plus 3 upon x. Once I observe that it is a difference of reciprocals, I will try to express right-hand side as difference of reciprocals. So I have to factorize 56, 7 factors. 15 is the answer. But I have to write it x square minus 7 square equal to 64 minus 49, 15. So difference gives me the answer 15, not the sum. 8 square plus 7 square will be different, but 8 square minus 7 square is 15. So I will write for 15, 8 square minus 7 square and not, and on the left hand side, of course, it is minus sign. That is also a hint for that. So we have a situation now, x upon x plus 3 minus x plus 3 upon x is equal to 8 upon 7 minus 7 upon 8. 8 square minus 7 square divided by 8 into 7 gives me 8 upon 7 minus 7 upon 8 and not roots but the values. X upon x plus 3 equal to 8 upon 7 and x upon x plus 3 is equal to minus 7 upon 8. Now I can find the value of x easily just by cross multiplication. First root will be minus 24, second is minus 7 by 5. You can check the answers. So even if I start solving this given equation by our routine method of cross multiplication, LCM, and so many things, just do that after going to home. Try to solve this particular problem, x upon x plus 3 minus x plus 3 upon x is equal to 15 by 16, 56 by our routine method. Have a LCM cross multiplication. So many times you have to adjust. Product will be 56 multiplied by something, 15 multiplied by something. Lot many calculations. Of course, time and energy both will be more required than what Swamiji has given us a technique for solving such examples where remember the condition is left hand side is a sum or difference of reciprocal and we must be able to express the right hand side rational number as a sum or difference of the reciprocals. Then only such thing will work that you can just equate two sides. Otherwise, you have to go by the regular way. This is a particular case I'm repeatedly saying, not the general one. And the last part, factorization of homogeneous second degree polynomial in two variables. In probably 11th or 12th class and more than that, we required to factorize ax square plus twice hx square plus by square. So what is the difference in the earlier equation and this is there are two variables instead of one. It is ax square plus 2hx square. This is a standard form and plus by square. Usually we have ax square plus bx plus c, but homogeneous second degree polynomial is expressed in a standard form as ax square plus twice hx square plus by square. Same Urdhva Sutra is applicable. And those who are familiar with such type of equation will know that or understand that these equations are always difficult to factorize. But let us see what happens with Urdhva. Again, factors of a and b means coefficient of x square factor and coefficient of y square factor are to be selected and written orderly in such a way that their cross product is twice h, means their cross product is coefficient of xy. So if I write the factors of a as a1, a2, same idea which we had done earlier, and the factors of b as b1, b2, I must have a1 multiplied by b2 plus a2 multiplied by b1 equal to twice h. That twice, we all know the reason for that. Once that is done, my factor again a1x plus b1y, not a1x plus b only. The factors will be a1x plus b1y and second factor a2x plus b2y. So by observation, many a times, we can straight away have the factors. What is the advantage of this? We know that such type of a homogeneous second degree equation in two variables always represents joint equation of lines. Of course, there is a condition. When this happens, when such type of equation is factorizable only when h square minus ab is greater than 0. You cannot write at randomly select a, h, and b. If you want to have a factors of this equation, then there is a condition. Similar to previous case, the condition to get a linear factor was b square minus 4ac greater than 0. Here the condition will be h square minus a into b greater than 0. If not, linear factors are not possible. We know under this condition, when this condition is satisfied, this equation means a polynomial equal to 0 represents a pair of lines or joint equation of lines passing through origin. There is always a problem, find the separate equations of lines when a joint equation is given. Means nothing but to factorize this equation and equate each factor to 0. We apply a technique of factorization as said before. Even in geometry, Urdhva Tiryagram will work and you will get the answer. Let us have a problem. See, I have given a problem straight away. Find the separate equation of lines 10x square plus 19xy plus 7y square. We arrange the factors 2, 5 and 1, 7. Select for 7. No other choice. Sum is 19. So first factor is 2x plus y. Don't call 2x plus 1. I repeat. Second factor is 5x plus 7y. Equate each factor with 0 to have the separate equations of lines. So equations of lines with joint equation is 10x square plus 19x plus xy plus 7y square equal to 0 is 2x plus y equal to 0, 5x plus 7y equal to 0. Clearly, it is a equation of lines passing through origin because constant term is absent in the equation. Let us try this. Have a hand. Find separate equations. Well, x square minus 11xy, 5. No choice for minus 5. 1 and 5 are the only choice. So select that way, 4, 3, 2, 6. I don't know what will happen. Yes, 3, 4 is okay. 3, 4 for 12. 1 minus 5. Give me minus 11. Yes, 15 minus 4. And in fact, the joint equation will be, separate equations are 3x plus y equal to 0 and 4x minus 5y equal to 0. So same technique of Urdhva Tiryagram can be straight away applied to homogeneous equations of second factorization for homogeneous equations of second degree in two variables, or find the separate equations of lines in geometry. Again, I must say that this is not, you will not find this in the book. This is our study of Swamiji's methods or application of those studies for in this different situations. Thank you for everything. I'm grateful to organizers for giving me a chance to deliver a lecture on the topic of my choice in this one-day workshop on different aspects and applications of Vedic Mathematics Sutras in various disciplines. I thank all the distinguished and enthusiastic learner teacher participants. Many of them I know personally for their cooperation. Namo Namaha. If there is any query, any doubt, any comment, you are welcome. Now I stop sharing. If you